Welcome back, everyone. So good to see you all again. Today is exciting. We're starting a new type of sequence. Let's just recap quickly where we're at. So far, we've had two different types of sequences. One where we have what we call an arithmetic sequence, where we get from one term to the next by adding a fixed number. The next type was geometric sequences, and those are where we get to the next type. Those are where we get from one term to the next by multiplying by a fixed number. Okay, the last type of sequence that we've got to deal with is what is known as a quadratic sequence. So let's dive straight in and have a look at these. Now, quadratic sequences are really cool. I think when one's a parent, one shouldn't have a favorite child. I'm not sure if, as a maths teacher, one should have a favorite type of sequence, but these ones are up there for me. Okay, I do love these. All right, now I can give you an example of a quadratic sequence. Here's one right here. 1, 3, 6, 10. Let's just quickly confirm that it's not arithmetic. If we subtracted, we would not get the same value each time. In other words, if we went 3 minus 1 to get a common difference, we get 2. Now we get 6 minus 3. We don't get a common difference. If we try testing it for being a geometric sequence, 3 divided by 1, 3, but 6 divided by 3 is 2. So we have not got a constant ratio or a constant difference. However, these sequences have a form that is actually a quadratic expression. In other words, something with an n squared in it. Okay? And they are characterized by having what we call a constant second difference. Right, a constant second difference. Now we're gonna look at kind of what that means. All right, like all of this maths, it makes an enormous amount of sense. Just making that highlighter a bit thicker. Okay, right. Let's take a look. Constant second difference. So here's an example. Now, if we look at the first differences, in other words, what we're looking at is we're looking at T2 minus T1, T3 minus T2. All right, those first differences are 2, there's a gap of 2, then there's a gap of 3, then there's a gap of 4, and then there's a gap of 5, and so on. Right. The second differences, in other words, the difference between the differences, okay, this is quite a thing, the difference between the differences is just 1, 1, 1, 1. And notice that these second differences are constant, okay? Right. Now, let's do another example. Why don't you just quickly write down the first differences for this one and the second differences. We'll just pause very, very briefly. Okay, not a difficult thing to do at all. We've got our first differences, 3, then 10 minus 5 is 5, then 17 minus 10 is 7, 9, 11, 13, and so on. Right, in fact, the last one here, that 13 was the last one. The next one would be 15. Okay, the second differences are 2, 2, 2. And notice that the second differences are common. Okay, so that is the deal with these type of sequences, is that the second differences are common. That's how we pick a quadratic sequence. Right, so we've got 3 types now. We've got an arithmetic sequence, a geometric sequence, and a quadratic sequence. Soon, when we've done all of them, we're going to practice mixing them all up and getting used to kind of the whole lot all together. But let's now turn over and let's have a look at how we could find the formula for the nth term. All right, this formula gets provided to us, but it's not all that helpful on its own. We need to know a bit more stuff. But because we know that our nth term is of that form, our first term, if n was 1, our first term would be a plus b plus c. All right, if n was 2, our next term, if n was 2, we'd get 2 squared, we'd get 4a plus 2b plus c. And if n was 3, we would get 9a, 3 squared times a, 9a, plus 3b plus c. Now let's, and in fact we'll do one more, right? And I know I haven't left us a lot of space here with the way I've written it, but if n was 4, we'd get 16a plus 4b plus c. So these are the first 4 terms. Now if we look at our first differences, the first differences are go that minus that. Now what you'll notice is that the c's subtract and cancel out. We get 3a, when we go that minus that, we get 3a plus b. That's the first term of the first differences. The second term of the first differences is going to be this term minus this term. What will we get? We'll get 9a minus 4a, that's 5a. We'll get 3b minus 2b, we'll get a b. And we'll get, the c's once again will cancel out, they'll subtract out. Let's write down the third term of the first differences. So that's this term, 16a plus 4b plus c, subtract 9a plus 3b plus c. And what we get 7a plus b, and once again the c's divide out. Now, if we work out the second differences, and we're going to do that by subtracting, we're going to take this minus this. Now the b's subtract out and we're just left with 2a. And notice the next one, the b's subtract out again and we're left with 2a again. So what is in fact true is that our second differences equal 2a. Now this a over here, I'm just going to sort of underline it let's just underline it in, let's just put a kind of orange box around it. Okay, this a is the same as this a over here in our formula. So if the second difference is 2a, then we know that, okay, let's just write this down. We can see that the common second difference, sorry about that, it's 2a. Right, so we can actually find a. What we can also see is that 3a plus b is the first term of the first differences. So let's write that down. 3a plus b is the first term of the first differences. And if we know a, then we can get b. But also, if we go right up to the top here and we look at a plus b plus c, that is the first term of the original sequence. So let's just write that down. A plus b plus c is the first term of our original sequence. It's T1 of our original sequence. And now if we know a and b, then we can also find c. Right, so we're going to come back to this. But this here is the process for finding the nth term of the quadratic sequence. Now, I'm going to just talk us through it. The first thing we're going to do, we're going to write down the sequences of first and second differences. Then we're going to calculate a, and that is just going to be the second difference divided by 2. Then once we know a, we can calculate b using 3a plus b as t1 of the first differences. And then we can calculate c using t1 of the entire thing is a plus b plus c. Right, and then finally, once we know a, b, and c, we can write down our answer and we can check it. Now, I'm going to highlight this in yellow. The reason I'm highlighting this in yellow, this is the only formula we get provided for quadratic sequences. This here is really important. We don't get given it, we need to learn it. Exactly the same with this here, and exactly the same with this here, although this one is fairly obvious as we'll see. Okay, the best way of us getting our heads around all of this is to do an example or two. So let's find the nth term for this sequence. So we're trying to find a rule, a formula to see which will generate each term of this sequence. The first thing we do is we write down our first differences. You don't need to write this, you don't need to write it all down, but for now, just while we do the first one, I'm going to write this down. The first differences, okay, I haven't written that very well, but first differences are going to be 4. So 6 minus 2 is 4. 12 minus 6, 6. 20 minus 12, 8. 30 minus 20, 10. We don't need to write too many down, that's enough. Okay, notice how useful it is to be good with numbers. So we're not like scratching around, we can just write them down. Okay, now underneath this I'm going to write the second differences. Okay, and the second differences are 6 minus 4, 2, 8 minus 6, 2, 10 minus 8, 2. These are fixed, all right? And remember, we are trying to find, and this is the only formula we get provided, we're trying to find the rule an squared plus bn plus c. Now, that gets provided. I'm going to highlight it in yellow, it gets provided, but what I'm going to highlight is I'm going to highlight in blue the other little formulas that we're going to use along the way. We know that a, all right, a is the second difference divided by 2. If you go back to the previous page, you can remind yourself why that is. All right, you don't have to know that, but it is useful to know where it comes from. So in fact, a is going to be 2, the second difference, over 2. For this particular question, a is 1. Right, that formula does not get provided. I'm going to highlight it in blue. Now the next little formula that we're going to need is the fact that 3a plus b is T1 of the first differences. Okay, and again, we did show that on the previous page why that works. It always makes sense. Okay, now, I'm going to highlight this in blue because this is not provided. Okay, but now what we know what a is. So in this formula, I'm going to write it out, but it's going to be 3, but I know what a is. A is 1. So plus b, that must equal the first term of the first differences. That must equal 4. I'm going to put that 4 in a circle because that 4 is that 4 over there. Right. How many variables are in this equation? Eli Lord, we can solve this very easily. 3 times 1 is 3, plus b is 4. Let's subtract 3 from both sides and we get b equals 1. Now we know a and we know b. Now, if the last one, which is, you don't really need to learn this as a formula, but if we wanted to find T1, look at this, T1 of the whole sequence would just be, if n is 1, then n squared is also 1, T1 would just be a plus b plus c. But we know what a is and we know what b is, so we can easily now work out what T1 is. What c is, okay? T1 is the first term of the whole thing. So 2 is equal to a. Now we know a is 1. B is also 1 plus c. So how many variables in there? Only 1, and we can get it, and we get that c equals 0. Okay. I'm highlighting this in blue as well. So guys, just make really sure that you understand this. The only formula you get provided is the yellow one. This one at the top. These 3 in blue you need to learn, right? What we've now managed to work out for this sequence, we've worked out the nth term. We know that Tn is 1n squared, a is 1, plus b is 1 as well, plus 1n, plus c, and c is 0. Guys, that there is the formula that generates each term of this quadratic sequence. Let's test it, okay? And it tells us at the bottom here. Let's test it. If we put 5 into our formula, T5 would be 5 squared using our formula plus 5. According to our formula, T5 would be 25 plus 5, it would be 30. Let's just check. 1, 2, 3, 4, 5. Halala. Bingo. Laduma. All right. Now, we're going to ask you to pause the video, and we're going to ask you to try and find the nth term for this sequence. Once you've done it, just remember to check your answer. Okay, we'll go over it shortly, but pause the video. When you're ready to have a look, let the video run again. Okay, let's see how you got on with that. All right. So it's very much like following a recipe. The first thing we're going to do is we're going to write down our first differences. Okay, and the first differences are 4. 20 minus 12 is 8. 32 minus 20 is 12. 48 minus 32 is 16. Those are the first differences. Okay. Now we're going to write down the second differences. 8 minus 4 is 4. 12 minus 8 is 4. And 16 minus 12 is also 4. As soon as we get a constant second difference, we know that this is what we are dealing with. We're dealing with one of these. Now there are 3 things that we need to find. We need to find A, we need to find B, and we need to find C. All right. We find them in that order, as easy as ABC. A is just half of our second difference. It's 4 over 2. A is 2. Okay. The next little formula that we need to find B is that 3 lots of A, now I'm filling in A is 2. 3 lots of A plus B is the first term of our first differences. The first term of our first differences is in fact 4. So 3 lots of A plus B is 4. How many variables are left in here? Ellie Lordwood, just one. All right, 6 plus B is 4. Subtract 6 from both sides. 6 plus B equals 4. B equals negative 2. All right, now we know A, we know B. We also know that if n was 1, then A plus B plus C, A plus, so I'm going to write it like this, A plus B plus C is the first term of the entire sequence, okay? I'm going to highlight that yellow, all right, and I'm going to write an 8 in here. Okay, so how many variables left in here? Also only one, and in fact C equals 8, because 2 and minus 2 cancel one another out, and we get C equals 8. Our final answer is Tn is 2n squared minus 2n plus 8. Okay, the last thing I like to do, just to sort of test ourselves, is I test a number in here. So let's test if, for example, we went with T3. According to our formula, T3 would be 2 lots of 3 squared. Now, careful, that's not 6 squared. We square the 3 first, all right? So 9 times 2, 18, minus 2 lots of 3. 2 lots of 3 is 6. So 18 minus 6 plus 8. According to our formula, 18 minus 6 is 12 plus 8. T3 should be 20. Let's just go and check. Is T3 20? 1, 2, 3. Halala. This is definitely right. Okay. Does it make sense? It always makes sense. You might want to go back to page, I think it was page 19. Let's just check. Yeah, back to page 19 where we derived why this works, okay? Because understanding why it works is really, really important. Okay, now we're going to ask you before the next lesson to try the next 2. Both of the questions on page 22. Question 33 and 34. And we look forward to seeing you next time and going over those and seeing how you did. All right. Have a great day. Bye.